Okay, now we're going to talk about geometric mean, and we have a foldable that looks like this. It's a pink foldable, and we're going to go ahead and fill this out with our geometric mean information. The first thing to do is to cut it out and fold it up. Now that we've got it all cut up and folded, we're going to go ahead and fill this out. So the first thing we're going to start with is geometric mean. And if you remember back to your algebra days, mean means average. It's where we take all of the numbers and we add them up, and then we divide by how many we have. Well, geometric mean is a little funky. So the geometric mean, the definition is the geometric mean of two positive numbers, a and b, is a positive number x such that, so we're going to set up this equation. It's a proportion. A over x equals x over b, which when we end up doing our algebra, we get x equals the square root of a and b. And I know this is really confusing, so I've got some examples down here for you to also write down so you can understand this a little better. So basically, x is our geometric mean. And how we find the geometric mean is we set this up with our number over x equals x over our other number. And when we cross multiply, we get x squared, and then we cross multiply these two numbers. So we get x squared equals 36, and then we just find the square root of 36, which is 6. So if you look up here, we're just multiplying the numbers together and then finding the square root. So here's another example, 4 and 25. We end up getting x squared equals 100, and then we square root that and we get 10. So that's geometric mean, and it's like I said, it's kind of weird, but it's important because when it comes to right triangles, we have some special relationships, which is what we're going to talk about now. Right, so now we have the right triangle altitude similarity theorem. And the right triangle altitude similarity theorem states that if an altitude is drawn to the hypotenuse of a right triangle, so we've got our right triangle here. I guess there should be a little box right here showing that this is a right triangle. And then we draw an altitude. If you remember, altitude is where the little man climbs the mountain and rappels straight down. So it makes a right angle here with the hypotenuse. So if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and each other. So now we have three triangles here, and they're all similar to each other. Now there's some rotating and spinning around that we have to do, but if we draw them separate, you would get these three triangles here. And then we would have this similarity statement. So that is what happens when we do that. Now the geometric mean and this play together to come up with these two theorems. So our first theorem is the right triangle altitude hypotenuse theorem. And what it states is the measure of the altitude drawn from the vertex of the right angle of a right triangle to its hypotenuse is the geometric mean between the measures of the two segments of the hypotenuse. Well, I've broken it down and I've given you a picture. So this right here is the important part. This is your key to solving these problems. So we have our right triangle with our altitude, and we have three parts. We have this part of the hypotenuse, we have this part of the hypotenuse, and we have the altitude. And what happens is we can set up a proportion. A over B equals B over C. So the part times the inside equals the inside times the part. And here's an example for you down here. So we have 4x and 16. So what we're going to do is we're going to set up 4 over x equals x over 16. Now, in my examples, I have the geometric mean as the unknown in all of these, but that's not always the case. Sometimes we'll know the geometric mean and we'll be looking for one of these parts. You just follow the same pattern. You're just going to use this right here and follow the same pattern. So when we solve this out, we get the geometric mean, or the altitude right here, the length is 8. Now for our last theorem on geometric mean, it's the right triangle altitude leg theorem. So this one we dealt with the hypotenuse. We're going to throw those legs in there now. So it states if the altitude is drawn to the hypotenuse of a right triangle, each leg of the right triangle is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to the leg. Lots of words there, right? So I've drawn two different pictures here because this one can go for either leg. And it's important to remember that. So how we solve this is we take the part closest to the leg that we're dealing with, which is labeled B, over my leg equals my leg over the whole thing. That's why you see B plus C right here. So we need to make sure and add these together. That's very important. And it's a step that a lot of students miss. A lot of students want to do B over A equals A over C. But we want to make sure and add these together. And it goes for the flip side also. So I've gone ahead and drawn you a picture and given you, not the formula, but the setup for it. And here's an example of this. So we would have 3 over x equals x over 3 plus 9. And we end up getting 6. Now, one thing to know about all of these different theorems, particularly these two, is the triangle does not have to be sitting on its hypotenuse. It can be turned around, it can be reflected, it can be, you know, several different ways, and they're still going to apply the same. So just keep that in mind as you work these problems.